Today we will be covering the Doppler effect and how this relates to radio velocity. This concept is not only an important tool in the field of science, but it's also very significant in astronomy. We use the Doppler effect to determine the radio velocity, and that is the velocity or speed that is going toward or away from us. We can determine the Doppler effect with this definition: the increase or decrease in the frequency of sound waves. As the source and observer move toward and away from each other. So with this definition, we can automatically see that the frequency changes due to positions of the source and the observer. So in the previous picture, we can see the source, which is the ambulance. I'll draw it out. So let's say this is the ambulance, and this is Tom. So as the ambulance moves away from Tom, the frequency is actually decreasing, because from this position, the ambulance emits a sound wave that has a greater frequency. As the ambulance travels 50 meters eastward from here, let's say the ambulance has moved to a position of X over here and emits sound waves like this. These sound waves will travel to Tom at a slower speed than these sound waves produced at this position, because the ambulance is closer to Tom over here, and more sound waves would be traveling past this fixed plane Q than if we say the position was over here. However, let's say there's a woman named Erica, and she's right over here. She's just walking by and drinking her Coca-Cola. The ambulance travels towards Erica, so the frequency on this side increases, while the frequency towards Tom over here decreases. The wavelength towards Tom increases, while the wavelength towards Erica decreases, as those are inverse relationships. So a note that I want to address is that when dealing with light, only the relative motion matters. So either the emitter or the observer could be moving, and that doesn't matter. We can use the Doppler shift of spectral lines to determine whether a star or an object is moving towards us or away from us. Whether it's getting red shifted, the velocity is going away from us, or it's getting blue shifted, which means that the velocity is going towards us. So if we draw a diagram right here, this is actually the hydrogen spectral lines, and say, let's say we have a dip right here, a dip right here, and a dip right here. This is the normal diagram that you will see with the hydrogen at no shift. This is the hydrogen of an atom or an object, and let's say if it moves to the right. And the initial position are at the dotted lines. This means that it's getting red shifted since velocity is going away from us. In another example, we can say that it's being blue shifted. So the dips would be on the left, and the velocity would be traveling towards us. And how does this relate to the relative radial motion of stars? Well, we can use this equation to find the radial velocity of stars and determine whether it's traveling towards us or away from us and at what speed. And this equation is lambda minus lambda naught over lambda naught equals the change of lambda naught. And this entire equation is equivalent to velocity over the speed of light. So the velocity would be the radial velocity, and that's the velocity moving towards or away from us. So if we find the final wavelength, which is lambda, and suppose lambda is 656.5 nanometers, and lambda naught is 656.3 nanometers, and if we subtract it and divide it by lambda naught, then we would get around 0.2, and lambda, the change of lambda over lambda naught is 0.2 over 656.3, and that's equivalent to 3 times 10 to the negative 4th power. So since we get this answer and this value, we can equate it to V over C. And if we multiply C to this value right here, then we would get the radial velocity, which actually turns out to be 90 kilometers per second. And because 90 is a positive value, then it would be redshifted. So it would be moving away from us. Always remember that negative velocity is moving towards us. And positive velocity is moving away from us. So it's being redshifted. If you know that these 2 points, if you can memorize these 2 points, then you basically have the equation down. And the answer that you get would always make sense. So thank you for watching this episode. Our next one will be about the colors of stars, thermal emitters, and more. Thank you.